Well, is the continuation of where we left off from like beginning this tutorial for microprocessors. My first stream, it was pretty alright, honestly. Now I got a little bit of gist, so let's just continue from there, I guess. In this lesson, you will learn to use push buttons with digital inputs to turn an LED on and off. Pressing the button will turn the LED on, pressing the other button will turn the LED off. The components required: one ELEGOO UNO R3, one 830 tie points breadboard, one 5mm red LED, one 220 ohm resistor, two push switches, and 7 male-to-male jumper wires. Okay. Let's get them then. So, microcontroller, as always. The breadboard, right? It's under here. Oh yeah, I'm gonna need some resistors too. Not sure what that is yet. Oh, breadboard. Keep this out. So we got the microprocessor, the resistor, the breadboard. All that's missing is the two push buttons. Where are the push buttons? Well, I'm gonna need some jumper wires, so this too. Huh. Or is it in this? No. Oh, they're right here. They're a lot smaller than I thought they were. So it gives me 5 of these, but we need 2 of them. I'm not sure why I got out 4. Okay, let's put this back. Put this back on top, and I forgot this LED. Okay, let's get the 220 ohm resistor. Let's put this back. Should be like the one on top, really, because that was the most recent one. Yep, here it is. Here's a little booklet. Just take one of these out. Okay. Let's keep this out so I could just easily put it back. I'll just put it like up here. Let's take out the breadboard. Standard from last time. Okay. So that's all we got. How many did it say? 7. Oh right, it did say I need a red LED. Let's take that out real quick. Ooh, I don't know about those wires on that. Okay, I'll just get what the picture says. So, let's untie this. Hopefully not make a huge mess. And perhaps a yellow one. And another black one. Component introduction. Push switches. Switches are really simple components. When you press a button or flip a lever, they connect 2 contacts together so that electricity can flow through them. The little tactile switches that are used in this lesson have 4 connections, which can be a little confusing. Actually, there are really only 2 electrical connections inside the switch package. Pins B and C are connected together, and as are A and D. Okay, here's the schematic. Should I suppose I should just wire it first then, huh? Okay. Yep. Down here. I mean, it doesn't really matter, but as long as the connections are good. Okay. LED. Ground. Assuming this one is the cathode. Okay. And let's orient these little buttons as so. Doesn't have to be exact, but enough. Sure, really should have really hit it with one of these. So I like. It's kind of a little awkward, but. Gets the point across. I just don't want to bend them too much. Really. Because it'll just mess it up in the future. So that's what I have so far. Let's continue. Oh, well, it seems I needed a. Hold on. 1, 2, 3, 4, 5, 6. I need another wire. Just pull one out from the middle. Hopefully it doesn't break. There you go. It's a tad bit longer, but it's fine. Okay. So I'll put the longer one connected here. Back to ground on the top. Oh, right. All the side... Oh, here we go. No? Yes, here we go. Everything on the side of it has this own little marking. So the little thing right here that says ground, or G and D, means ground. What else? Okay, from this point, we're going to head over to 5 with the little line. I mean, I could put it from the back here, but image says to put it there. So I'll come 5. Kind of looks a little awkward, but it still does the job. Just like bend it or get a longer wire. But hey, I already got him. Oh wait, it doesn't go there, does it? It goes here. Onto the supply line. Wow. Can't believe I didn't notice that. This from ground goes there. I messed that up. Okay, let's take this little blue wire, set it to the 9 with the line. Okay. And another black wire going from the other pin. Are these good? Yeah, they're good. Going from the other pin line, or like the node, going into 8. And this other pair, same thing for the other button. Going from this node to... Oh wait. Oh no. I'm stupid. This is supposed to be jumper from here to the power. And the yellow was supposed to go to the 8. Wow. How could I miss that? Same thing goes from this line to the power supply. Oh. Seems like they didn't puncture these too much. I'll just jump over the red. It's fine. And like that, we have every button connected to the power line, and the ground also going to there. For some reason. Well, actually, I guess that would be the more like the return line now I think about it, because every single one of these wires would be a power supply. So, yeah. The resistor here, LED here. This is how it's shown, but not necessarily the green wire, but it's a good reference for ground. Alright, continuing on. As you can see, I made it as such. What I believe is gonna happen is... Actually... Now looking at this diagram, these little buttons should have some little markings on them for their orientation. Because... yeah, they should. I may have placed them wrong. They want the switch part in the middle. They want B. Interesting. I'll just place them. Just see how it goes. Alright, then they should be in that orientation then already. Hopefully. There we go. Set it over here this time so that the resistor isn't bending that much. Moving on. Although the bodies of the switches are square, the pins protrude from opposite sides of the switch. This means that the pins will only be far enough when they are placed correctly on the breadboard. Ah, that makes more sense. Remember that the LED has to have the shorter negative lead to the left. Ah, okay. Coding. After wiring, please open your program in the code folder, lesson 5 digital inputs, and press upload to the upload program. Well, given that what I actually have isn't part of that, I'll have to investigate real quick. So I found it online and I downloaded it. So let me just change this window capture. Digital inputs, here we go. Load the sketch onto your... Okay, wait. Code. After wiring, please open the program in the code folder, lesson 5 of digital inputs, and press upload to the upload to upload the program. If errors are prompted, see lesson 2 for details on about tutorial on program upload. Load the sketch onto your Uno board. Pressing the left button will turn the LED on. Okay, hold on. Let me just... Well, that out of the way, load... Okay, let me load it. Let me just... Oh yeah, I should probably get my battery loaded. Oh, there it is. Now let me upload it. Alright, it's done uploading. Now, if I unplug this and power this on with something else. Now, let's see if it works. I have this plugged in. Oh, right, I have to put this in a lower power setting. There we go. It's on. On. Okay, so let's see. Oh, let's try to turn this back over. There we go. So, if we were to press this button, it turns on. Press it again, keeps starting on. Press this one, turns off. Press it again, keeps it off. That's cool. Yeah. Let's go over the code, see how this all works. Okay, so we labeled the pin as the 5th one. Yeah, we did, huh? LED pin. Pin mode LED. Yeah, there we go. And button A pin, which is the first button, I'm assuming, has the 9 with the line. And button B has 8. Okay, setting it up. Pin mode LED pin output. Pin mode button A pin input pull up. Pin mode B input pull up. Huh. Okay. If digital read button A pin equals low, which means it's not being pressed, that means that the LED pin is high. Oh, wait, no. If it means it's low, that means it's being pressed? I'm assuming. And for if digital read button B pin is low, digital write LED pin is low. So the LED pin, which I'm assuming is the red one, which is 5. Yeah. So if that one's a high, then that means that LED is high or low. Wait a second. Oh, this is about breaking connections? Okay, that makes sense, since if there's no more connection on the A, that means that it's a low. So then the LED rewrites itself to have a high for the red wire, and it maintains that. Like, even if it becomes high again, there's no if for it being high, or for it being high, yeah. Only when it disconnects. But if the button B is low, that means the disconnect is disconnection, even momentarily, that means it's low. Okay, okay. Input pull up. What is that? I'm not too sure what that means. So if I were to disconnect that, it still wouldn't do anything weirdly. Hold on, let me go through this logic real quick. So it's the output. So, okay. So is it based off bursts rather than like actual input? I sort of understand what this is trying to get at. Let's zoom in a little bit more. So here's the open. Maybe that's better. I don't know. So I have it connected to power because all the code is already uploaded here. So let's turn this off. Okay, so from what I can understand, so if that is if there's a low from this one, then that makes it send power to over here to the LED. But if I turn this, if I push that, that means that there's a connection here, which makes it not send any. Which is weird because, like, I could take off this wire, like this black wire for the first one, tap it a little bit here, and it turns on. But if I were to tap it here, it turns off, which is quite strange. And the same thing if I were to do it the two. So that means this makes a connection rather than destroys one. which gets me confused as to why. Oh, as to why there is a low on the code. So if I were to use this wire, oh, and touch it over here with the yellow node, turns off. Which only gives me the only thing I can imagine is that this makes a connection, and if there is a signal from here, it turns it off. It deletes power. But if I were to maintain both these, it still turns on. But if I leave off, oh, it cuts the power, by the way, which is weird. Just if I press it once, if there is a single high on the connection for A, it turns this on. But on the actual code, it says digital read button A pin if it's a low. So that's one thing I don't fully get. Since button B also reads for a low, then it sends a low. But if it's high, let me just clarify which one is A and B. So A is the one being connected to 9, which is the blue wire, which is the one on the left. And yeah, so it only reads an input if there is a connection, which not sure why that would be a low. Well, we have a button set up. On and off switch. If you hold both of these down, it still turns on. If we let go of the B, it's brighter. But if we let go of the A, or the button A, yeah, it turns off completely. Which I find strange, but it kind of makes sense in a sense, you know. If there is a connection for button A, it turns it on. If there is a connection for B, then it turns it off. So I get that gist. It's just that the code I don't necessarily understand completely. So yeah, let's just zoom out now. Zoom back out. So yeah, that's neat. Just wipe down this table. Oh, one thing I forgot to actually read it to see what it actually all means. Okay, load the sketch onto our Uno board. Pressing the left button will turn the LED on, while pressing the right button will turn it off. The first part of the sketch defines 3 variables for the 3 pins that are to be used. The LED pin is the output pin, and the button A pin will refer to the switch near the top of the breadboard, and the button B pin to the other switch. The setup function defines the LED pin as being an output as normal, but we have 2 inputs to deal with. In this case, we use the set pin mode to be input pull up. The pin mode of input pull up means that the pin is to be used as an input, but that if nothing else is connected to the input, it should be pulled up to high. Ah, I still don't get it. In other words, the default value for the input is high, unless it is pulled low by the action of pressing the button. This is why the switches are connected to ground. When a switch is pressed, it connects to the input pin to ground, which is no longer high. Since the input is normally high and only goes low when the button is pressed, the logic is a little upside down. We handle this in the loop function. Okay, so that's what my confusion was. In the loop function, there are 2 if statements, one for each button. Each does a digital read on the appropriate input. Remember that if the button is pressed, the corresponding input will be low. If button A is low, then a digital write on the LED pin will turn it on. Similarly, if the button B is pressed, a low will be written to the LED pin. Ah. So that's lesson 5. That makes some more sense now. Let's move on. Lesson 6, Active Buzzer. In this lesson, you'll learn how to generate a sound with an active buzzer. Component required: ELEGOO UNO R3, active buzzer, 2 female to male DuPont wires. Interesting. Using different wires this time. Alright. Let's get the components. This little thing charging my phone. How do the buzzers look? Are they in here again? Couldn't have lost it because I never opened this. Ah, well then. Man, I should really expect these things to be a lot smaller. I'm guessing this is the passive buzzer. Okay. Well, we got the buzzer. The active buzzer. Remove sealing after washing. Whoa. Let's put it in the circuit for now. Let's put it like right there. I think we need some of these. Ooh, that got tangled. I have no idea what this is. I believe that's what these are. Yeah, female to male, a DuPont wire. These are so much more resilient. Do I just peel them off? I guess. Female to male DuPont wire. Ah, we're gonna connect it to the buzzer. Oh, that makes sense. It's fun to bend. Well, I need 2 of them, so I'll just get the black and white one. Peely peely. I feel like I did something I shouldn't have. Should I? I don't know. I don't know if I should have done that. Feels wrong. It really does feel wrong. But here they are. So felt really wrong to do. Here's the things. Got the little, oh shit, buzzer, little buzzer thing. See if I can focus. There we go. Remove seal after washing. Oh, it doesn't say we need the breadboard though, so I guess let's just set that aside. Okay, let's go back to the PDF. Component introduction. Buzzer. Electronic buzzers are DC powered and equipped with an integrated circuit. They are widely used in computers, printers, and photocopiers, alarms, electronic toys, and automotive electronic devices, telephones, timers, and other electronic products. For voice devices, buzzers can be categorized as active and passive ones. Turn the pins of the buzzers, or the 2 buzzers face up. Wait, what? Turn the pins of 2 buzzers face up. Wait. Turn the pins of 2 buzzers face up. The one with the green circuit board is a passive buzzer, while the other enclosed with black tape is an active one. The difference between the two is that an active buzzer has a built-in oscillating source, so it will generate a sound when electrified. A passive buzzer does not have such a source, so it will not tweet if DC signals are used. Instead, you need to use square waves whose frequency is between 2000 and 5000 to drive it. The active buzzer is often more expensive than a passive one because of the multiple built-in oscillating circuits. Wow. Inside this little thing, there's a connection. That's how it's supposed to look. Well, let's get to it then. Okay, let me switch it over. Here we go. Code. After wiring, please open the program code folder. Okay, okay. So, I feel like I should upload the code first. I'm gonna do that. Let's just open active. Here we go. Here's the code from the folder. Let me upload it. And it's uploaded. Let us connect it to my battery. And now let's switch over to hand cam. Okay, so this goes to ground. And this other one has to go to 12. As shown there. To 12. Huh. It's... Wait. Well, let me hold it up to my mic. You hear that? And it's buzzing more. That's a long one. This is actually buzzing. It's pretty cool. A comically long cable. Okay, now let's go on to the code. It doesn't explain it, so... It doesn't explain it for some reason, like the other one. I'll try to interpret it though. Let's go. Oh, I'm gonna turn this off. So, buzzer pin 12. And pin mode buzzer output. So the buzzer is gonna be the actual output for the digital write, I believe. Okay, sound duration of 504. This is a for loop. Starting at I, going until 20. Well, 20 times since it starts at 0. But it does stop at 19. And every single loop it adds up until 19, I believe. So if I is less than 5, the sound duration is 500. So that's the beginning. I equals less than 10. Then the sound duration is 300. Else if it's less than 20. Activate the active buzzer. Digital write buzzer high. Delay sound duration. Digital write buzzer low. Then it turns it off. Then delay sound duration. So it uses the same amount of time as it's on and as it's low. And then it says the high for 5 seconds. Then it does that for 5 times. because it's a for loop. So it goes until 19. So it does that 20 times. But then after the loop is done, then it sets the actual thing for 5 seconds. And then it loops again and it restarts the sound duration at 500. Okay, this one is not that complicated since it kind of looks like Java, to be honest. And I'm more familiar with that because of my programming classes. I know Java is like not too popular, but still. On to the next. Lesson 7. Passive Buzzer. Overview. In this lesson, you will learn how to use a passive buzzer. The purpose of this experiment is to generate 8 different sounds, each sound lasting half a second. From alto do, 523 hertz, re, 587, mi, 659, fa, 698, so, 784, la, 880, si, 988, to treble do, 1047. Everything required the same except for a passive. Well, let's get that. I believe it was this one. Yes. Let's put this one back. Now let's go back. Component introduction. Passive buzzer. The working principle of the passive buzzer is using PWM generating audio to make the air vibrate. Appropriately changed as long as the vibration frequency, it can generate different sounds. For example, sending a pulse of 523 can generate alto do. Pulse of 587, it can generate mid-range re. Pulse of 659, it can produce mid-range mi. By the buzzer, you can play a song. You should be careful not to use the UNO R3 board analog write function to generate a pulse to the buzzer, because the pulse of the output of analog write is fixed, 500 Hz. It's the schematic. Wiring diagram. Alright, let's get this wired up then. So, same principle. I don't believe there is anything specific about this. Oh, wait, no, there is. There's a positive and negative on this one. But it doesn't really say anything with that. But I'm just going to assume the negative to be ground, so. Dang, why did it shift around? And going to 8. Alright. So that's it. Let's go back. Wiring the buzzer connected to the UNO R3 board. The red positive to the pin 8, black wire negative to the ground. I mean, I didn't use a red particularly. Black wire negative, wiring the buzzer connected to the active. I mean, I did that anyway because I assumed negative would be like a voltage drop, so I connected it to ground. Okay, after wiring, please open the program in the code folder. Click upload to upload the program. Alright, let's do that. And I dropped the wire. Let me turn off the... Oh, compilation error. Library. Ah. I see. Well then. Seems there's a issue. Okay, let's see if that resolved the issue. Hey! Maybe that works. Done compiling. Oh, there it goes! Haha! Let me show it off. We managed to upload it! I had to do some trickery with the folder, but now let's plug it in. Yeah, I could do some little funny things. Yeah, that's pretty cool. You could make like a little jingle. Alright, that's getting quite annoying now. Let me press reset. Yeah, it just starts the program from 0. Well, that's cool. Let's take these off. Well, that's the passive buzzer. That's the passive buzzer for you. Well, that was lessons 5, 6, and 7 on the tutorial PDF. I hope you enjoyed. Tested the button. Tested the... what was it called? Active buzzer, and now the passive buzzer. So, I feel like that was some useful things that I'm assuming will be used more in the future in some of these lessons. Thank you for watching, and goodbye.